right, so one other thing we need to know is that this is also not just called the standard form, but this is also called the vertex form. All right, so those names are interchangeable. So sometimes I might say standard form, and sometimes I might say vertex form, but they both are referring to this formula. Okay? So to graph these quadratic equations, we need to first write it in standard form. So we need to convert it and change it so that it looks like this. Okay? As soon as our equation looks like this, y equals a, and then in parentheses, x minus h squared plus k, our vertex is at hk. Okay? So if we can get that equation written in that particular order, then we know exactly where the vertex is. Well, what is vertex? What does that mean? If this is what a quadratic looks like graphed, where would it be? This right here would be our vertex.
Wow. We had some smart kids in this class.
Okay, so that would be our vertex. So then the other thing that we know, once when we have our vertex, is that we also have something called the axis of symmetry. And that axis of symmetry would be x equals h. Okay, so x equals h, that's x equals some number. So that means we have a line. Okay, and if it's x equals, it means that we have a vertical line. So what that tells us is that if here's our diagram of our quadratic, this would be our axis of symmetry. X equals h. It's a vertical line that goes through our vertex. Now, why would we call this the axis of symmetry? Yeah, we could cut it in half and fold it over. So the right-hand side and the left-hand side are symmetrical. So if we have a point right here on the right-hand side, if we reflect it across our axis of symmetry, we'll have that same point on the left-hand side. Okay, so that axis of symmetry, and that's going to allow us to graph these pretty easily. Bless you. And then the very last thing that the standard form tells us about is it tells us which way it opens. So if a is greater than 0, so if we have a positive number out in front here, so if this value is positive, that means that we open up. If it's less than 0, so if it's a negative number, then we're going to open down. That should make sense because positive numbers are up and negative numbers are down. So what we're going to do is I'm going to give you an equation. We're going to write it in vertex form or standard form. Once when it's in that form, we're going to find the vertex, the axis of symmetry, which way it's opening, and then we're going to graph it.
Are we going to get the formula for like x or anything?
All right, so here's the first equation. Y equals, and then in parentheses, x plus 2 squared plus 1. Good, this is already in standard form. What are some clues that this is already in standard form? Y equals. That's one thing. We have a y equals here, so the y is already alone. And then over here, this is x minus h squared, so we should have something squared. Do we have something squared already? Yeah. So this is already in standard form, so there we wrote the equation in standard form. That's a very good question. This is going to affect whether our h value is positive or negative. Okay? So in the standard form, we have x minus h. So that's a standard form. And then from here, we can say that our vertex is hk. So in this case, we have x plus 2. So what would the value of h have to be? Yeah, it'd have to be a negative 2. So we kind of think about taking the opposite sign in the parentheses. All right, so the vertex here, we already got the h as negative 2. And what's your k value according to this? 1. Okay, so the vertex is at negative 2, 1. All right, next up, axis of symmetry. What will be the axis of symmetry for this parabola or this quadratic? Up here it tells us that it's x equals h. So what's our h value? Negative 2. So our axis of symmetry is x equals negative 2.
Why is it a negative 2?
Because in the standard form it's x minus h. So right here that says x plus 2. So in order to really think about it in standard form, you'd have to think x minus a negative 2. So your h would have to be negative in order to get that to say plus in the middle.
So just whenever you're positive,
Anytime we're in the parentheses, you're going to end up just changing the signs. Direction of opening. So that's based off of our a, which is our number in front of our parentheses. So what number is in front of our parentheses here? 1 is. So is that positive or negative? It's positive, so that means we open up. So it's finding the vertex axis of symmetry and the way it opens okay from this. Okay, so now let's graph it. So to graph it, what do you think we're going to start with? The vertex, right. Plot the vertex. So we're going to plot the vertex at negative 2, 1. Okay. I am going to dash in an axis of symmetry here at x equals negative 2. So it's going right through the vertex. That's not part of the quadratic graph. It just helps you graph it when we get a few other points. Now, because we have this nice symmetry across the axis here, if I pick a point to the right of this and I find what value it is over here, I can just reflect it to the other side. Okay? So when we're trying to graph it, we just need to pick 2 points. And we want to pick 2 points either directly to the right of our vertex or directly to the left. It doesn't matter which way or which side you use. You just have to use one or the other. And you'll just make an XY chart to figure out what your Y value should be. So here, my X is at negative 2. So I could use the point negative 1 and then the point 0. And I could take these and plug them into my formula and figure out my 2 values for Y. Okay, so if X is negative 1, so x here is negative 1. So negative 1 plus 2, what does that give us? 1. And 1 squared is plus 1 is 2. So negative 1 gives us a 2 value for our y. Do the same thing for 0. So 0 plus 2 is 2. 2 squared, 4. 4 plus 1 is 5, so 0, 5. So we'll plot those 2 points as well. So negative 1, 2, and 0, 5. Now because we have that axis of symmetry, it's symmetrical, so that means if we have this point here, I can reflect it across that axis. So how do I know how far over to go on the other side? Yeah, just go 1 over. I'm 1 away here, so I'm going to go 1 away here. Up here at this point, I'm 2 away from my axis, so I'll go 2 away and plot that point. And we can do that because it's symmetrical. Okay, and then you just have to connect these and make it look like a quadratic. So there's our graph. Is that okay? Do you guys remember graphing these from Algebra 1? Yes, but in Algebra 1 you had to do an XY chart of everything. All right, so now we just have to find two of these. Yeah, you did. All right, let's do another one. So y equals 5, and then in parentheses, x minus 3 squared minus 1. So first thing, We need to decide if this is in standard form or not. It is already, okay. So it's already in standard form, so there's nothing we have to do to it. So there's our standard form or our vertex form. So based off of this, now we want to state what our vertex should be. Okay, so here's our general form, y equals a, x minus h squared plus k. So what's my hk? Yeah, 3, negative 1. Okay, my axis of symmetry. 3, but we want to write it as an equation. So we would say x equals 3. And which way will this open? So what's the a value? 5. Is that positive or negative? Positive, so this will open up. Is that okay? Okay, so now let's graph it. So what's the point that I'm going to plot first? Okay, so 3, negative 1. There's my vertex. I'm going to lightly dash in my axis of symmetry. That way, when I get the other 2 points, I can easily reflect it. All right, and now I need to pick 2 points.
How do you determine if it opens up or down again?
It opens up if the a is positive, and it opens down if the a is negative. So it's a positive, so it opens up.
What points do you pick?
Okay, so what points do we pick? So the points that we're going to pick is we look at our axis of symmetry. We see that this is at 3. We want to go the closest 2 points to it, either on the left side or the right side. Okay, so here you could plug in the points 2 and 1, or you could plug in the points 4 and 5. 2 and 1? Okay. It doesn't matter which 2 you pick, you're going to get the same values for y. All right, so if x is 2, so let's plug this in up here. So we'd have 2 minus 3 is negative 1. Negative 1 squared is 1 times 5. It's 5 minus 1 is 4. Okay, when x is 1, so we have 1 minus 3. It's 2. 2 squared, 4 times 5, 20 minus 1 is 19. Okay, so 2, 4. So 2, 4 is right here. 119, way off our graph. So I'll just put a point way up there somewhere. Okay. So if I have 2, 4, I want to make sure I reflect it across my axis. And I also know that way up there I've got some other point reflected across. Then we want to draw in this quadratic. So there's our quadratic. So in the previous example and in this example, the value for a changed. So in this graph, the a was 5. In this graph, the a was 1. What can you tell me about the difference between how these 2 graphs look? Yeah, the bigger the number, the skinnier this parabola gets. So if we get a smaller number, like a half or a third, how's the parabola going to look? Yeah, it's going to get wider. Okay.
Will we get fractions?
Will you get what?
Fractions?
Yeah, some of them will have a fraction out in front. All right, so now we have to do some problems where what happens if we're not already in vertex form. Okay? Because it's not always going to be given to us in that form.